Hey guys, welcome back to Miss McIntosh math session. So today we're going to look at how we solve multi-step equations. All right. All right, so in solving a multi-step equation, we can sometimes distribute first, use the distributive property, then combine like terms, as you see in this example here, or we can combine like terms first, then distribute. It depends on what you are given in the problem, all right? So we are going to use this problem here to show you how we solve a multi-step equation using different approaches. So here it says, a math teacher recorded the distances he rode his bike last week. He challenged his class to find the number of miles he rode on Thursday. How far did he ride on Thursday? So in order for you to solve this problem, you need to know what the problem is asking you to find. So as you see here, I always highlight what I am finding. Either I circle it or I underline it. So I want to know how far he ride on Thursday, mean how many miles did he ride on Thursday? So on this picture here, we have Monday, Tuesday, Wednesday, Thursday, and Friday. So on Tuesday, it didn't go anywhere Monday, and notice it didn't went anywhere on Wednesday. On Tuesday, he rides 4x plus 3 miles. On Thursday, it was x miles. On Friday, x plus 7 miles. And Saturday, x plus 7 again. We can use an equation to represent this situation, all right? It's easier to use an equation to represent this than solving it as it is. So to create our equation here, we are going to write the information based on what we have on the table. So based on what we have here, this is saying the distance he rides on Thursday, Friday, and Saturday is equal to the distance that he rides on Tuesday. So we are going to have for Tuesday 4x plus 3. All right, so the distance from Thursday to Friday, Thursday, Friday, and Saturday, we have two ways we can write it. Either we can write x plus 7 plus x plus 7, or we can use factorization to write that part. So we're going to use factorization where we have x plus 2, because we have two x's, right? And two 7s. And in parentheses, we are going to have x plus 7. Okay, so this is one way of writing it, or we can just write it out as it is in the table. However, I just want to minimize the number of terms here, so it's better to write it like this. So now that we have our equation, right, we are going to solve. Remember, when you solve an equation, the goal is to isolate the variable. Isolate means getting the variable on one side of the equal sign, whether it be the left or the right. So if you notice this problem here, we have parentheses, right? So we cannot solve it with the parentheses, so we need to get rid of it. To get rid of the parentheses, we have to use what we call the distributive property. Distribute means to multiply. So you multiply the factor outside with each term inside. All right, so let us do that and see what that looks like. So we're going to multiply 2 times x, which is positive 2, because we have a plus there. It's going to be positive 2x. And then we are going to multiply positive 2 times positive 7, which is what? Positive 14. So there you have it. We distribute. Now, what we're going to be doing is writing all of those numbers, terms that we don't use yet. We're going to write them back. Put back our x there. We're going to have 3 here on the left-hand side. Okay, so one of the things I normally do, I normally label my equation, left-hand side and right-hand side, so we can see what we are working with. All right. All right, so now we have this. We do our distributive property. Now, if you looked on the right-hand side, we have what we call like terms. So in order to simplify the equation, in order to solve it, we need to reduce the number of terms that we have to one variable term, all right? So we need to combine those two like terms that we have on the right-hand side. So to combine them, we are going to add. The reason we add is because we have an addition sign between the two terms there. So we have positive x plus 2x is equals to 3x. How do we get 3x? Remember, when you're combining like terms, what you do is to add or subtract the coefficient and keep the variable the same. All right. Now that we condense the right-hand side by combining like terms, we are going to move to the left. If you notice on the left, we don't have any like terms there. So we're going to write it back. Going to write whatever we have there, write it back. Now, we are down to a regular multi-step equation here with variables on both sides. So remember now, once you reach this stage here, you are going to put your variable term on one side of the equal sign. As I said before, whether it be the left or the right, and put your constant on the other side. Because remember, you are isolating the variable to find the value of x. So to do that, I normally remove my smaller variable term and put it where the larger one is. So I have a positive coefficient because I don't like to work with negative coefficient. Therefore, I am going to move my 3x and put it where my 4x is. But in order for us to do that, we need to do what we call inverse operation. Inverse operation says whatever is happening, you do the opposite. So here we have a positive 3x plus 14. In order for us to get rid of the 3x, we need to do the opposite of addition, which is subtraction. So we are going to subtract 3x from here. If I subtract, this is going to be gone. I am going to have on my right-hand side plus 14, just the 14 there. And if I take away 3x from the right, I do the same thing to the left. So when I do that on my left, I am going to be left back with x plus 3. And on the right, I'm going to have 14. So let me just go over here so you can see clearly what we're doing. So we have x plus 3 equals to, so same color, equals to 14. All right, let me just erase this positive sign here. Yeah, plus 4, 40, plus 14, 14 is the same thing. So you don't have to write that positive there. All right, so now we have a regular one-step equation. We are going to go ahead and isolate x by getting rid of the positive 3. To do that, again, we use inverse operation, which is the opposite of what is happening to the 3. So we're going to take away 3 here. If I take away 3 on the left, I do the same thing on the right. So this cancels out. This is 0. You know, x plus 0 is going to give you back x, so we don't have to write that 0. So if you take 3 from the left, you do the same thing to the right as we said. So 14 minus 3 is equals to 11. And there you have it. The value of x is 11. Remember now that the question asks, how far did he ride on Thursday? Remember that x represents the distance he ride on Thursday. So he ride 11 miles on Thursday. And you can always check your answers to see if that the value of x is true for the equation. All you need to do is to substitute the value of x back into the equation. So here, this is the original equation right there. 4x plus 3 equals x plus 2 in parentheses, x plus 7. So here, 4x means 4 times x is going to be 4 times 11. 4 times 11 is 44, plus 3 is 47. So on the left-hand side of the equal sign, we have 47. Let us check the right now. So here we have x, which is 11. Inside the parentheses, we have another x, which is also 11. So here we're going to simplify the parentheses first, because we can add 11 to 7. 11 plus 7 is 18. 18 times 2 is 36. 36 plus 11 is 47. So you notice that the left-hand side of the equal sign is equals to the right. So therefore, the value of x is true because it satisfies the equation. And there you have it, how we solve a multi-step equation using distributive property and also combining like terms. Thank you for watching.